from Brain Art and Brain Sculpture. So after the last video where we were talking about how we are hardwired to watch out for tigers and spiders and things, that's going to make a bit more sense to you, the reason I'm using tigers here. Because we still have that Stone Age brain that looks out for what's going on in nature to keep ourselves safe. And we can use that mechanism, and we do use that mechanism to also kind of add to it, if you like. So it's a bit like thinking of like a hashtag or something. So, we've got hashtag, tigers, that's risky. But we have a mechanism where we can sort of add to those files, if you like. So, if we have a fright, and just before the fright we're saying, "Oh, I had like a great time. This is really good. It's really fast, or it was really fun, or something like that." We encode that. So, if you like, that kind of saying like, "Oh, this is really fun," becomes like a tiger. Our brain's going to respond in just the same way and activate the amygdala. Or it might be that we have a fright and our brain encodes all the sensory information that's around. So it might be a particular perfume or a colour or the way the sky was or the date or the time or the weather or the year um, and what we were thinking and our body position, um, patterns that are around, scents, maybe a taste now, maybe we were, eating a sweetie or something, so it's minty. And we encode all that information and we use that information in the future to predict risk. So when we make a sensory matching, so we're using it's on the surface. So often in therapy we're talking about, oh, it's deep or it's layers, but it's on the surface. It's like an antivirus system. It's like a burglar alarm. It's matching that sensory data, and the response is really fast. It's a really quick response. So we're scanning. We're scanning all that information all the time. So it's right there on the surface, and it's so quick. Just like I was saying in the last video, we tend to miss this part of the process, and instead we notice when our heart starts beating, or we have some other kind of physiological symptom or response or result or a pattern of behavior that we do where we sort of think, I don't like this, or I'm out of here, or perhaps we're kind of fascinated by it and want to do it more and more because our brain's looking for a new way of doing it, looking for kind of solution. So it's very interesting. So so brain sculpture is a kind of fun name for talking about neuroplasticity. We're all doing brain sculpture. We're all learning all the time. Whoever we are, whatever neurotype we are, whatever experiences we've had, um, we may think we're not good at learning, but we are learning all the time. Let's look at what that mechanism looks like. There we go. So this is sort of diving into the brain here. So what you're seeing there is learning in action. So you see the movement, that electrical movement in the neurochemicals. We call that traffic, and that's a sort of signaling system. And so we're seeing presynaptic neurons and a postsynaptic neuron. So there's the one at the beginning, and then there's one that looks like it's catching it. So these two, you can say they're attracted to each other, and then they come close like this, and then one of them sends information, and the other one opens up doorways, creates doorways, and sends them to the surface of the neuron. You can't see it in this film, and that's how the traffic comes through. It's allowed to pass through these doorways. Now, what our brain does as well, and 30%, so if we imagine these as networks, 30% of these networks are also doing the opposite. The doorways are reabsorbed and the signal can't enter. So the sending neuron moves away, and that's called delinking. So when the process begins, it's called potentiation, and that's how we learn. And when we've learned You know, when we have that connection and the traffic can flow through the open doorways that are made in the postsynaptic neuron, and they're called receptors, AMPA receptors and different kinds of receptors. That's learning. We've learned something. And that's why we do a lot of repeat learning. It's where you learn things at school and it's repeated and it's repeated. But if you think about it, learning's also fast. You know, think about the first time that you taste something. You think, wow, that's really good. And when we get a fright, the learning is super fast. And it happens in a different part of the brain. It happens in the right amygdala. So we're knowing more and more about this all the time. We're knowing more about potentiation and depotentiation. And they're learning processes. And through that, through how we're using our brain, how we use our neuroplasticity, we can engage with our neuroplasticity because we have tools that we can use to do that. We're actually changing, you know, which areas of our brain are active. And so they've done research into looking at, for instance, the hippocampus of taxi drivers. And parts of that hippocampus is larger and some parts get smaller because of how they're using navigational skills. We looked at the brains of musicians and people who speak two languages. And so we know, we have the science that we're all capable of changing our brains. So think about some things that you're really knowledgeable about. You know, it might be you know loads about different kinds of cars or what babies like or soups or horses or whatever it is that interests you, and just notice what a fantastic learner you are. And you know, look at how you learned that, and you can realize that you could apply that strategy, whatever your strategy was, to anything you want to learn. And then it's a case of just finding the right information, the teachers that suit you, and using your own strategies. But we are fantastic learners. And that when we think we can't learn, guess what? It's our friend, the right amygdala, is active. Because when we're faced with uncertainty, when we're faced with risk, that's not the time to be learning. So by calming down, by down-regulating the action in the amygdala, we are more able to learn. And when you check out those strategies of what you know lots about, you'll probably find that there's a lot of sort of joy and enjoyment in learning them, and you were kind of quite curious and playful and excited about knowing more about them. So enjoy learning. So brain sculpture is another word for neuroplasticity. It's the action of what happens when we learn. We change the shape of our brain. When we change the shape of our brain, we change which areas are more active, there's more activity there, then that's going to change how we respond in the world, what our perceptions are, what our emotions are, what we perceive is going on, you know. So whether we think somebody's, you know, how we see them or how we see our environment. And we have those skills now to use, so we can, and I believe that when you understand what's happening in your brain and the kind of control that you have over your brain, then the things that are scary become understandable. And with that comes a kind of curiosity, and with that there's a reduction in fear. And when we're less afraid, then the amygdala is much calmer, and we can use other areas of our brain. It's exciting, isn't it? So let's look at how we do things. So let's look at brain art in the next film.